As the camera sweeps across the forest floor, what do we have here? A small cluster of geometry nodes mushrooms, growing rapidly before our eyes. Fascinating little things.
Hello everyone, I hope you are doing well. In this video, I will try to do a breakdown of the node setup I used to make this little mushroom animation. Before we start the video, I want to touch on 3 points briefly. The first one is try to recreate this yourself. When I usually watch tutorials, I always try to make the effect I see in the video by myself, and then I watch the solution or the tutorial. You don't have to recreate the entire effect. Just take like 10 or 15 minutes and try to walk through the main steps to try and make this. That's all. I noticed that when I struggle and make effort in order to achieve something, that's the best way to make stuff stick in memory. So you kind of learn the different workflows, what notes to use when. I learned that when reading a book called Make It Stick. I get a lot of messages asking me about the music I use in my videos as well as the sound effects. The service I use is called Epidemic Sound. So they have sound effects as well as music, but also they added this feature called Voices, where you have real voice actors that actually agree to work with Epidemic Sound to provide their voice. Then you can use AI to do the narration. That's what I used in this video just saw. They recently sent me a mail offering a 25% discount to people who use my link. So I will share the link in the description, and you also need to use the code community25. Full transparency, if you use my code, I get a free month, but you also get a 25% off, so it's a win-win. I'm not trying to shill Epidemic Sound, but it's a service I genuinely use. So if you find yourself needing music or sound effects, feel free. The last thing is, I'm still learning geometry nodes, so if I make a mistake, or you see a workflow that's not the correct way to do things, please let me know in the comments. Before we start, it is really important to understand the concept of instances. Let's take a simple example. So I started with a cube, right, and then meshed the volume, scattered some points inside the volume, and then I instanced some icospheres inside. So this is the icosphere, right, without anything, and then I tried to displace the icosphere, okay? So I'll plug this, sorry. The way I did that is just using a noise texture, right, and then modifying the amplitude of the normals, and then being able to having this scale to control the intensity globally. Then plugging that into the offset of set position node. That way it allows me to displace. This is quite standard, but yeah, this is not the point of this example. Let's see, but you notice that all of these instances have the same noise pattern. So the question is, how would you go about randomizing the noise pattern for each instance? The simple answer is you can't. Well, at least not without breaking instancing. So what I mean by that is that instances by construction are meant to be the same. The only thing that might differ instances is what we call, so these are driven by what's called transformation matrices, right? A transformation matrix. So there is scale, rotation, and position as well, which is defined by the position of its points. So you can see here, scale and rotation, they are fields, right? So we can plug a random value for each instance, and it will change that for each instance, right? But what we're trying to do here is different, because we are trying to displace each point for every instance. This is different because when we use the scale here, for example, when we plug the random value, the field is related to these points, right? We randomize the scale associated to each point on the cube. But what we are trying to do is randomize each point on the instance. It's quite different. So let me pull out. This is the Houdini documentation. They're called packed primitives in Houdini, right? And I find this graph to be quite helpful to explain the concept of instancing. I will try to make a simplified version. This is not how it works. As I said, it works using transformation matrices, but this is just an example. Let's say this is my original object I want to scatter, right? I can store, for example, the origin of the object, and then all the vertices on this object, right? So let's say these branches are all the vertices. Sorry for the drawing, I'm not using my tablet. And then let's say I store all the position of the points, right? So I know this vector, I know the distance, I know this vector as well, and this one as well. So I know all the distances between the center and this point. And then I store this information inside my memory, my RAM, right? When I instance, all I need to know is, or store, is actually the center of each instance. Because once I have the center, I already have the relative position to the center. I can just place all the points correctly by moving them from the center with this relative distance that I already have stored in the memory. So I don't need to calculate it again. I already have it. So I just need to know the center, and then I can infer the relative positions from that. That's why packed primitives or instances don't take a lot of space in memory, because they only need to remember the initial point we're using. So as I said, this is just a simplified example. So to solve our problem, there are 2 methods. The first one is what I will be using in the tutorial. So instead of showing it here, I will show it directly with the mushroom setup. That solution is actually to randomize what's happening before the instance on points. So it's like setting up a collection, you know, when you set a collection with different types of rocks, and then you use the collection info node, right? Use this one, and it has a lot of, it contains multiple meshes, and then you check this box, pick instance to choose between different instances, right? You can do that. We're going to do that directly inside of shader nodes, inside of geometry nodes, sorry. So we're not going to be using any external collection. And the second method is this one. So this is where you lose what I said earlier, without losing instances. This is what I meant. So when you use this node called realize instances, you move from here having 68 instances to having a lot of points, right? It will place each point. It will store the position of each point individually. So after this node, you'll lose the power of instances, which is the fact that they are fast to tweak. So this is actual geometry. And after that, we're going to have to move our setup. So let me take, this setup, shade smooth, this as well, Shift D, right? And then here we can plug this here, set position, and then plug the scale into the offset. And here you can see, but since here you can notice that we're no longer playing with the values for each instance, so it's like the noise field is like global this time, so we're gonna have to do some tweaks as well. It's not gonna be the same noise pattern. Is not going to work. I can tweak the scale as well, maybe something like this. Yeah, you can see I have a different noise pattern for each. No, sorry, it's 0. Yeah, like this. And then for the scale, I'd have to have a really small scale here as well if I plug this. Then make this 0, 1, for example. Yeah, you can see it's actually very hard to, you don't have the same level of control. This is why I prefer the other method where you set it up before. The idea is that you can play with the noise field globally for all the instances. There's probably a way where you can capture the origin of each instance and then use that as the vector to drive the noise. But yeah, this is the other way. I'm just giving you the general workflow, is that you'd have to realize your instances before doing any per point operation. Okay, now let's check out the mushroom node setup. I will first of all isolate them so that you can see things more clearly. We'll start here by going through the first step. Okay, so I started with a circle. Okay, I then distributed some points on this circle. I used this node merge by distance just to tell whether, so here I can define if 2 points, right, are too close to each other, this is the threshold, they will be merged into one, right? So that way I can sort of control the number of points this way as well. It's just that I wanted to avoid too many intersections between the mushroom stems. So once we have this field, you can obviously tell that this is the one we're going to use. So yeah, I named them seeds. These are the points we're going to use as origins from which our curves or stems will be spawning, right? So it will go all through here until the last instance on points, right? But we'll worry about that later. Now let's see. The other thing I used this for is so remember how I told you earlier, this is the first method. So I showed you the second method before, and this is the first method and the one I prefer better. So instead of using an external collection of different stems, I will create this variation of stems directly here inside using what we call a repeat zone. So this is like a for each loop. It repeats a certain operation multiple times, and the number of times that defines this the number of times that defines this is this variable here called iterations. And it's quite simple. So how many times do I want to have my curves? I want as many curves as I have my seeds, right? So this is what I use this node for, called domain size. It will just calculate the number of points. So here you can set it dependent on the type of your geometry. I set it to point cloud because this is a point cloud. This is just points. And then it will output the number of points, right? And this will drive the iteration number. That way I'm pretty sure I have the exact same curves, the exact same number of curves as seeds. Okay, so how do I create the stems? Let's see. I start with a curve line. Sorry, I can't talk English. Going up, right? Length, 80 centimeters is too much, but I think I tweak the scale at some point. Maybe, I don't know. We'll see. I start with a curve line. I resample it, right? To give it some more. Hold on. I don't know if if I do wireframe. No, it's not a visible wireframe. So it adds a lot of points so that when I introduce my noise, I have some points to play with. And then this is where I introduce the noise. I'm using a set position node. And then same as before, I'm using the offset to offset each point by a random value coming through from this noise texture. And here's the difference. So in order to have a different variation for each stem or each curve, I'm using the iteration as a driver for the W value. Yeah, the W value allows you to change to move across the noise field. So if I do this, I check my noise. Let's just unplug this. Now you can see when I change my W, it's like I'm moving through my noise field. It's similar as if you did an add vector for your position vector and then kept adding a value. Let's bring this back. And then, yeah, I'm plugging this into, I'm scaling, yeah, let me show you. I'm scaling this noise because I wanted the noise to affect the center of this more than the tips, so top tip and bottom tip. And a parameter that's very important when playing with curves is called the spline parameter. So it has some handy variables here. One of the important ones is called factor. So this is just an attribute that moves from 0 to 1, right? Or 1 to 0, I don't remember. But yeah, the order doesn't matter. We can change that as we like. So it just maps the length of the curve from 0 to 1. So if we try and visualize it, let's see. Try to show you. Yeah, so you can see, yeah, this is 1. And then if we go to the bottom, this here is 0, right? I think if I disable attribute text, yeah, you can see the color, it's more visible. So you can see it starts from black and then goes all the way to 1. So I will use that, and then I will use compare it with 2 values and then multiply those. So if I visualize this one here, if I visualize this one instead, you can see, so what I say is, if this returns a boolean. So if the factor is greater than 0.14, it will output 1, otherwise it will output 0. And then I multiply. It's like doing 2 boolean operations, and this allows me to control the top and bottom part. So if I play with this, you can see it controls how it controls the mask here, and same for this one, it controls the mask from the bottom. This way allows me to tweak, to define, so where all the things is equal to 1, I will be, yeah, I'm using this blur attribute here, it helps as well. So if I turn the iteration to 0, you can see that when it's 0, it will scale my noise by 0. So it will not be, this part will not be affected by any noise. But when it's 1, it will fully be affected by the noise. And the reason I introduced this blur attribute, just to not have these sharp transitions. So with the blur, you can make it a little smoother. Yeah, like this. You can play it. You can use it however, you can tweak it to your heart's content. So yeah, I hope you understood this part here, where I scale the power of the noise, or the amplitude of the noise, sorry, depending on where I'm placed in my curve. And then, yeah, this is just a global scale, right? I can, yeah, it scales everything by the same amount. This is a global scale. And here, yeah, this last one allows me to constrain, you know, when you move objects like this, you have your cube and then you press G and then Shift Z, and then it moves only on the X, Y plane. This is exactly the same thing. So I want my noise only to affect X and Y and not to affect the Z position. So that's why I put 1, 1, 1 and then 0 here. And this allows me to have, because let's say I put 0, you'll see that my noise is only working on the X axis. Whereas if I put 1 here, and then this one is 0, it's the opposite, right? It only moves, the noise only moves through the Y axis. But for me, I want it to move in a radial way, so on both axes. That's why I put. And then for Z, yeah, it doesn't matter because I don't want any noise through the Z axis. Yeah, and all this is driving my set position. And then here I convert my my curves into instances. And then I join it with the previous instance, because remember, our final goal is to create a collection of multiple curves. So if we see the output of our repeat zone, you can see we have a sort of a collection of multiple curves, and each one is actually different from the other. It's not the same as before, because you can see the noise texture here. I'm driving the noise texture with the W iteration. So it's for curve number 0, it will be 0. For 1, it will be 1. And this will modify the noise texture per element. I hope that's clear. Now we move to the animation itself. Let me cut this value. Keep in mind that at this point, these are still curves, right? So geometry means it could be curves, it could be meshes. Point clouds, I think, no, I'm not sure if point clouds are included. But yeah, geometry includes both meshes and curves. So you can still use curve nodes in here. So this is the magic node called trim curve. It allows us to move a curve along its, like to trim, yeah, the curve. It's sort of going through that U. In Houdini, it's called curve U, but here in Blender, they call it factor. It's like, yeah, going through the factor and then moving it down. You can either move it from the start position or the end position. If we check this growth animation, you can see, yeah, before we do, so yeah, you can see here I'm plugging it into the this little node set here. But let me show you manually what this does, so you can see I can trim my curves from start to finish until the full length of the curve that is defined by this value here. So I can tweak this maybe, yeah. And then what I did here is very simple. So there's this node called scene time that represents the number of frame at which the time the cursor, the playhead, sorry, is at, and then I just remap that into the number of frames. So let's say I wanted to start from frame minus 20 until frame to 2060. So this is the full length of my animation. It will remap that to a value of 0 of 1, because if you notice, my end factor here is between 0 and 1. That's why I did that. So that way I'm sure that my animation will spawn. My animation's length will be exactly this value. And yeah, you can see here it doesn't start at 0 because I put frame. So now I'm at frame 1, right? But I started from frame minus 20, which means at frame 1 it's already above 0. That's why it doesn't start here. Okay, the next step is meshing, what I call meshing the stems. So defining a radius for the stems. And we do that using the classic node set curve radius, where you give it a, curve to mesh, where you give it a profile curve and the curve. And this here just allows you to define the radius of your curve. So if we look at this, this allows you to define how thick the curve is going to be. And for that I used, again, the same parameter I told you earlier about, factor. So which means it will be here, I think I inverted it, so it goes from 0 to 1, and I remapped it from 1.2 to 0.3, so I inverted it. So for the low values, the radius is going to be bigger, and for the bigger values, it's going to be lower. And here, this is just a global multiplier, because I can tweak the thickness of my radii here. And then here, I just stored this attribute because I will use it later in my shade in. It's just a mask that it's literally linked to this range for the animation. So it's just a value going from 0 to 1 that will move as my stems grow. So it's literally just a representation of time, quite literally. And then I will use it to tweak the hue of the mushrooms, the color. Yeah, nothing special. And in this curve mesh, I use the curve circle as a profile, and then it gives me this. I don't need to fill caps because my mushroom head will be on top of this. So before we move to this last step, let's see how I placed my mushroom heads, or hats as I call them. So this is the same as before. I'm using an instance on points. Let's see these points here. So the points I'm using as instances are what comes out of this. So these, right? So this will output each point on each curve. So that's a lot of points, right? But what I want is, okay, hold on. Let me remove the selection. You'll see what I mean. If I move the selection and then come back, you can see that all of my shroom hats are instanced on each point of this curve, right? Because I resample it. And this will be defined by, if I go back, and then let's say I take this down to 10. So this defines the exact number of mushrooms I will have on my, so let's say it's 2, okay? And then here, I put this at 1, you will have exactly 2, right? 2. I don't know if you can see them, here's one here, right? If I put 5, because these are a lot of stems, for each stem I will have 5 points, which will scatter 5 heads, right? So let's go back. And this was 200. I will plug back my selection. I will explain how this selection works, but before that, just want to show you, this shroom head is actually made by hand. So I'm using a, let me see, where is it? Hold on. So let me hide this. Yeah, I think I disabled it. 1 second. Yeah, this is the shroom head. So if you see here, I will pull up a properties panel. Sorry. Give me a second. Yes, here. I'm using the exact same method as the previous tutorial. So I'm literally using object. I'll select this. You can see I'm using a curve, or a curve, or I'm extruding. I started with a single vert and then extruded multiple points to define the profile. And then I'm using a screw modifier and then a subdivision surface modifier. So this allows me to change the shape of my mushrooms as I like. Actually, let's change the shape, because I think the shape I picked is not that pretty. Maybe something like this. Let's see. Yeah, okay, why not? Let's disable this and then enable the scene. And then solo this again. Okay, these are my new shrooms now. Okay, so let's go back. So this selection here in my instance on points allows you to define the exact points you want to be used as scatter points. So I don't want all of them, right? I want only the last one. And the way I do that is, again, using this spline parameter with the factor. And I just told it to compare the value of the factor. So when the value is 1, if you remember earlier, we saw that it starts from 0 and goes to 1. So when the factor is 1, you put the shroom on there. That's the selection I will be using. And the rest, so this returns a boolean. And the rest is going to be 0. So that way it will only select the topmost point. I hope that's clear. And then here for the rotation, yeah, I'm using this curve tangent is also, it outputs a tangent vector, and I will be using that to control the rotation of my hats. And then here for the scale, so let's mute this. What is it? Oh yeah, this is just, and here for the scale, I'm using the exact same mask as before, the one that represents the scene length. So that means that my mushrooms will actually grow as time goes on. You see, it will get bigger. And here is just a remap, so I want them to grow steadily. I don't want it to be linear, right? I want it to grow fast at first and then be more linear at the end. So if I go to the end of you can see that my shrooms are kind of bigger. Okay, so these are all clumped here because I'm not instancing my last points, because if we look at our meshes, you can see they are literally quite on top of each other. So it's one mesh on top of each other because this is just a collection of stems. But once they are scattered on our seeds here, the distribution will look better. And translate instance, yeah, I don't know why. Yeah, I'm not even using this, so we can just delete it. Okay. And then we go back to this last part where we associate each stem with its respective mushroom. So let's see here. You can see the number of instances is 16, and it will be the same number of my seeds, right? And then if we take a look here at our hats, you can see that the number of instances is also 16. So we have a one-to-one association here. So we just need to associate each stem with its hat. And then you can notice that for this association, it's the position of the hats is already correct because I'm using these endpoints as the point where to put the hat. So if you notice, hold on, I'll zoom in. Wait, actually, I'll go back so that it's clearer. So look at the tips here, and then I will switch to my hats, and you will see they will be placed exactly at the same points. Now we just need to tell this instance on points node that this hat here is the same mesh as this stem, right? And the way we do that is I struggled at first, but I asked for some help. So I'm part of this Discord group made by Erindale called erindale.xyz. There's a lot of helpful folk out there, so I encourage you, in case you're going through your journey of learning GeoNodes, to take part in that group and then ask questions or ask for help. People are really helpful there. So someone on that group helped me come up with this little node setup that allows me to associate each stem with the hat using the index. This is how it was explained to me. So what happens in Blender is when you capture an attribute and then join a geometry, and then there's like obviously new geometry that is added. For that attribute, the geometry is going to take the value 0. Let's try something simple. Hold on, let me try and find merge until I only have like 3 points. Okay, good. Let's see now. If we go back, normally we should have only 3 here. Okay, so let's say this is so for the group of representing stems, this is going to be index 0, this is going to be index 1, and this is going to be 2. But then when you join it with these other 3 hats, these didn't have index at first, so they will be 0, and then this one is going to be 0, and then this one is going to be 0. Same for the other way around. So the other way around, let me change the color. It will be 0, 1, 2, and for the stems they will be 0, 0, 0. So what happens is what we do here is sort of like joining these two. So when we add the 2 indices, we will have, so this will be so 0 from the yellow with 0 from the pink, it will be 0, 1 and 0, 1, 2 and 0, 2, and then here it will be 0, 1, 2. And you can notice that for each hat and stem, we have the same value for the index, right? And that's what we will be using in the group ID here to separate between instances. Because if you notice, here when I join my geometry, if we look, we have 6 instances, right? 3, 3. But then when we realize the instances, it's no longer an instance, it's a bunch of points, so it's a mesh. But when we use the splits to instance nodes, it needs to have a way to discriminate between the points to know which point, which set of points corresponds to the same instance. So I need to tell it that all the points from this stems and all the point from this hat all represent only one instance, and same for this one, same for this one. Now, when I use this group ID with this, I'm telling it that whenever you encounter points that have the same index, join them as one instance. So when I see the output, I come back to 3 instances because this is 0, 1, 2. Yeah, and I forgot, since this is the point at which I will be joining geometries, I made sure to set a material for our stems, because once I'm at this point, they will be joined with my mushroom hat, so I just gave them a material. Okay, now let's take it back to the value. I think it was 7, maybe. Yeah, 7. Okay. So this is the collection of my shrooms, right? Now this, I'm using this group. This is like using collection info. right? This is like using a collection info, and then you point to an external collection where you have a bunch of different variations of rocks or plants or whatever. But in my case, I already have the variations. We created them for what we did before. All of these operations serve to create this sort of variation. But the advantage of this is that because when you do it with an external collection, you're limited by the number of variations you already created manually, right? But the power of this is that the variations are created procedurally, so I can at any point I want change the exact number of variations I want. I can change the noise field, I can change the shape of my head, or the size is what I have a lot of more control than doing it the manual way. And now finally, we just literally scatter the instance. And now, you make sure to check this. It's the same way you do it when you refer to an external collection. When you check this, it will pick for each. It will iterate between the different values. So for index 0, it will give it one instance. For index 1, it will give it another one, and then it will cycle through. If the number of instances is lower than the number of points, it will cycle through and start again from instance 0. But in our case, we are 100% sure that the number of instances is exactly the number of points. So we'll just put instance number 0 on point 0, instance 1 on point 1, and etc. Now, when we check our instance on points, you can see that it's scattered quite a bit. So now when I check my animation, you can see that the instances are grown individually. And then you can use, if you notice that your animation is slow in the viewport, you can use a bake node to bake the animation so that it's cached in RAM, and then it's going to be faster. So that's all for the node setup. I hope you learned something. If you have any questions, make sure to drop them in the comments. And also, if you want me to do a separate video for the shade-in and scene setup, like the way I set up the scene, the cameras, and everything else, feel free to let me know in the comments as well. And if enough people want me to do a video about that, I will try to record that as well. Have a great day.